Hi everyone, and welcome to today's TaskGen paper overview session. So recently, we have created a TaskGen paper and ran some experiments. And today is the day that we will be sharing through what we have found and how TaskGen can be also used for your own applications. So just a shout out over here, we have our talented contributors. First up, we have Prince. Say hi to everyone, Prince. I think you need to speak something for your...
Yeah, sorry. I'm not accurate. Hey everyone. Yeah.
And we have Hardik.
Hello. Hi, everyone.
Yeah. Brian.
Hey.
Richard.
Hello.
Yeah. And also today we also have Alan Crit here with us.
Hello, everyone. Nice
Yeah.
to meet you all.
So what exactly is TaskGen? TaskGen is a new kind of approach to do agentic frameworks that do not focus too much on conversation, but goes by solving the task first. The prompts will all be very goal-directed, task-directed, and assigning each of these subtasks into either functions or other agents. I'll be covering through more of this in the later parts of this session. But I just want to acknowledge the people that have sort of funded this project as I did this as part of my PhD work. And this is actually the final paper of my PhD. So thanks so much for AI Singapore and NUS for helping me through the 5 years, and for Symbian for recognizing my talent and encouraging me to pursue this route. So I'd like to give some time for Alan Crit to maybe just talk about how Symbian is using AI in the cybersecurity services.
Thanks so much, John, and very pleased to have you kind of working with Symbian and support the development of TaskGen. It's an amazing framework, and we're utilizing it in production for our own needs. So there's good synergy in kind of supporting the open source efforts as well as solving some real customer pain points. Briefly about Symbian, so maybe I can start with myself first. So I'm the co-founder and CTO of Symbian. And we are a generative AI-based platform for security. And the idea is that we're building a baseline platform where different agents will sit and help automate a lot of different workflows that will streamline security operations in different parts of the organizations. So for example, we have a GRC agent that helps with compliance requirements like filling in security questionnaires and helping organizations remain compliant to various compliance standards like SOC 2 and ISO and a few others as well. We also have a SOC agent that helps people in the security operations. So these are the people who tackle alerts and incidents. They read threat reports and perform like proactive procedures that are called threat hunting, for example, stuff that's basically meant to keep the bad guys out. So a lot of very, very important high value work. And there's lots of other agents planned as well on top of the kind of same underlying platform. And one reason we're excited about TaskGen is that security itself is a very fragmented industry. So on an average, for example, in an enterprise, you are dealing with 25 plus different kinds of security tools. So the design of TaskGen, where you break down the kind of action space and the what's called equip functions into different agents, and they work with different parts of the stack. That's very helpful in how we are thinking about solving security using TaskGen. And really looking forward to sharing key insights with the open source community and welcoming contributions as well. But yeah, that's it from Symbian. And John, you can take it forward.
All right, thanks, Alan Crit. So don't worry, TaskGen will forever be open source because this is actually the project that I will be maintaining over the next 5 to 10 years as I pursue the vision of fast learning and adaptable agents. So before we move on, I just want to show you a recent project I just created with TaskGen over the weekend. So this took about 1 to 2 hours to create with the TaskGen conversation class. Basically, my prof, Mehul, he wanted to do something to do iterative learning. And so let me just share with you this game. So it's easier if we just take a look at it while it's being played. So let me see. Okay, so this is the game here. So basically, you have to this is a graph with some points. You need to sort of guess the thing, and then you can just key in your stuff like, okay, I think it is y equals to minus 0.5 or something like that. Yeah, you can key in here. And the LM will actually know the answer, and the LM will try to guide the user to, get the right answer. So it looks like it does not match. Remember, all coordinates have value of y minus 1. So like you can say like, okay, shift it down by 0.5. So it can do this kind of flexible interpretation, and then out comes the answer. And the LM will then say whether it's correct or not, because it has the ground truth. So you can proceed to level 2 and so on. So back end, this is actually the conversation class, and you can see that at every step, the agent would think about like what the user provided, give some summary, and then outputs the reply. And at every point of time, we also compare to see whether the user provides the correct equation. So this is using the conversation class of TaskGen. Behind the scenes, a lot of stuff is actually rule-based, like how to generate this graph is so on is rule-based. I'll do another session of LMs in production to describe more about like how I think LM should be used in the process. We shouldn't do a full end-to-end agentic structure. That's too dynamic and too flexible, and it's not very reliable. So a mixture of using LMs for the things that really matter, like for those flexible output, and using some rules for the other parts, that's the key thing to go. Okay, I will cover this on another session. Today is not the session to run through this. I just want to get everyone excited about the possibilities of using TaskGen for complex projects. Okay, you can just interface them in a chatbot like this, or you can do other things like personal assistant and so on. All right. Can you all see the slides again? Thumbs up if you can see it, just to make sure that everything's okay. So today we'll be running through the basic features of TaskGen and also focusing on the experiments that we have done using TaskGen. So what are the key features right now in TaskGen? You can see them in the GitHub. There are a few tutorials that are created. Just run through these tutorials is as good as a crash course on TaskGen. Mainly focus on tutorial 0 and 1. These are the main ones. Tutorial 0, StrictJSON teaches you how to use StrictJSON to pass outputs of an LM into a structured JSON format. After that, the agent tutorial will teach you how to equip functions. I'll be showing an example of this later on as well. And the key highlight of TaskGen is actually tutorial 2, which is how you can share information between agents. Okay, there are other stuff like memory in tutorial 3, how to stack hierarchical agents in tutorial 4, code generation, tutorial 5, and conversation interface, tutorial 6, which is what we saw earlier in the equation game showcase. So firstly, what is StrictJSON? So let me share with you some background about why I created StrictJSON. Back then, at the early beginnings of LLM output was very, very verbose. Let me just show you how it was like. So for example, what is the meaning of life? All right, if you ask GPT this, it will give you a very, very long text. Sometimes actually all you want is maybe a short excerpt or some number. And if you ask LMs to reply in JSON format, you realize that it's actually a concise switch that turns on. So because JSON in the web is typically very concise, very to the point, asking LMs to reply in JSON actually significantly reduces the amount of tokens that are output. And these tokens are more or less the ones that are important. So this JSON is actually a hack in order to get the LM to return you the most important information in a very concise manner. Okay, and what's more, if you do your JSON keys one by one, like thoughts, observations, actions, you can actually do chain of thought prompting with JSON. So all these factors led me to use JSON as the default mode. And I think this is something that is very, very important, especially for production environments where you want the output to be of a certain format. So StrictJSON actually also has type formatting. Let me show you this. Like, you can actually put things like, I want to do a type list or type int and so on. So all you need to do for StrictJSON, give a system prompt, which is what you want the LM to do. Give the user prompt, which is the input, like the function input. And output format, you can come out in 3 words. Okay, what are your labels? What are your keys? And what are your descriptions? And you can put a type at the back, like enum, list, string, dictionary, and so on, to sort of constrain your output. And using an iterative process, the LM will be prompted to adhere to this format. So this is StrictJSON. It was created because there was too much free-flowing text of an LM, and I wanted to make it reliable. So I spent 2 years creating StrictJSON. Now it's of a quite a usable state. It works well with GPT, Llama, Claude, Gemini, and so on. You can try out your own LMs and see whether it works. So why StrictJSON? Why not use the typical Pydantic or JSON schema? This is actually a slide I wanted to emphasize on. This is also in the paper. JSON schemas are not designed for LLMs actually. JSON schemas are designed to encompass a lot of information, like here parameters, type objects, properties, and so on. But can you see a lot of them are redundant information, like parameters, we actually don't really need all this, like properties, you actually don't need that word. So if you can take out only what is needed and put them in a very, very concise format, you get the StrictJSON schema, where if you look at the bottom here, we have the location, city and state, and so on. So we only take in the keys and the description of the keys without the words description and properties. So this cuts down a lot. You can see it cuts down almost 50% or even more if you extend this number of parameters. The StrictJSON schema, in the same amount of tokens, you can at least represent twice or more functions. And this is very important. Okay, why is this important? It's because people have done like needle in the haystack and like other experiments that show that extended context length actually leads to poorer performance. So this is from a meta paper on rotary positional embeddings, and you can see that the typical rook, after like about 8,000 context length, okay, this rook L score is just a measure of how close the answer is to the ground truth. It drops drastically, which means that the attention span of such LLMs would not do very well for large contexts. I mean, you could do other methods to extend the context, but the fact remains is that if you could have a shorter context, you would actually reduce the amount of like hallucinations that the LLM would have. The context length matters a lot. Okay, this is the main point I want to emphasize. And StrictJSON is built in order to minimize context length so that we can pack more into the LLM. And this is just a brief slide on how StrictJSON works. We basically use the hex delimiters in the keys. So you can see over here, we have the hex. And because, JSON, sometimes you have like unmatching quotation marks, semicolons, or like brackets. So all these things are very irritating to deal with, and JSON.loads would fail for those. So StrictJSON, I spent like 1 year thinking of this problem, and this is the solution for this. You use a delimiter here, you split by the delimiter here. So regardless of what value is written here, I don't really care. Okay, as long as I have this delimiter here in your values, in your keys, you are able to get the keys and values out reliably. And you can see that this is the prompt. You can just copy and paste the top prompt into your LLM, and then your output here would be passed by StrictJSON to split into keys and values, and then do the type checking and so on. So this is how StrictJSON works behind the hood, and this is also why it's more performant than the JSON schema, because it can do a lot more things and still be able to pass out. All right. Oh, by the way, if you are thinking about this, this StrictJSON works also for like not just GPT-based LLMs. It can work for other LLMs as well. So this is essentially a JSON mode for other LLMs. Okay, so enough advertising for StrictJSON. The reason why I talk a lot about it, because I'm actually very passionate about that. So TaskGen is building on this concise framework of StrictJSON to build into an agentic structure. And this is the key philosophy behind TaskGen. So the main thing is, for a general agent in the environment, you can do many actions. Like you take, for example, a human. You can do you can walk, you can run, you can drink a cup of coffee, you can stand up and so on. There's a lot of things you can do to solve like a task. The task could be like, I would like to go to eat something. So you might need to take different actions, like I need to walk to the fridge, I need to open the fridge door and so on. How do we know what to do? Because there's infinitely many possible actions, right? If you think about it, if you don't have a limitation of your human body, you can do so many things to reach the fridge to get the item. So how do we actually solve such a problem in a generic environment? And the answer to that is actually, we have to be a bit more focus on what action spaces we have. We cannot just think of the whole set of action spaces. We must only care about the action spaces we have. Because if you cannot fly, there's no point thinking of a plan that makes you fly, because you will never do that. So what we need to do is we need to think about what we need to do next in terms of what we can do, what our abilities are, what our skills are. So in order to solve this generic task, our agent needs to know what are the specific skills that it has and tries to pattern match them to solve the task, either pattern match or formulate a plan and so on. But the main thing is we need to constrain the plan based on the actions available to us. Okay, so some of these actions actually can be easy. So you could just directly like walk, you can call a function call to maybe do the walking step, or you can call a function call to do the run and or open the fridge step. But some tasks are a little more difficult. Like for example, if you need to unlock a combination lock to open your fridge, okay, or I mean some more difficult tasks. You can pass on the more difficult tasks. Like this is a multi-step task, not easily done by one function. You could essentially pass on this task to another agent that could do the planning, that could do the iterative processing of the environment feedback and come up with the next action and so on. You can do that with another agent. And this makes it even more, makes the meta agent here even more, it has more abilities. So you can think of it like this. This is like maybe your CEO of the company. And then like at the bottom here, you have people like engineers, AI experts. We have people, UI experts and so on. Yeah, you can think about it like that. Like typically, if we want to just use one of this, okay, these are actually things that, it could be quite hard to actually do all this already. All right. And if we want this guy to do everything, can you imagine how much workload this guy would have? Imagine if your CEO of your company does every single thing that all the employees do. Yeah, I don't think the CEO has enough time to sleep, right? And that's too much information, too much context and requirements given to this person. So the way to do problem solving is actually assigning things. Like a good leader knows how to assign things to others. And these inner agents could increase the capacity of your main agent by taking on complex pieces of the puzzle. And overall, your meta agent will be able to solve greater things. So this is actually one of the key insights of TaskGen is that we do not want, like, unlike frameworks like maybe AutoGen, we have people talking to one another and so on. We do not want actually everything at the same level. Like hierarchy is still important in terms of solving problems because, yeah, and this will be in the next slide, the information required to do the next actions and the action spaces for the meta agent and the inner agent are actually quite different. Like if you think about it, what does the CEO need to know? He needs to know like profits, need to link up with companies, that kind of stuff. But these people over here, what do they need to know? They need to know latest trends, they need to know, like maybe for the UI experts, you need to know how to use Figma, and so on. So like these are the kind of things that each people will have separate knowledge and separate requirements. And if you want all of these requirements to be at the top level, it's going to be a cognitive overload at the top level. So this hierarchical structure is quite elegant and it enables everyone to have each agent, let me just put it here, each agent will have a different abstraction space, okay, and also a planning space and also action space. So the context given to each agent will be specific to that agent's need to know, because like for example, the CEO, the meta agent doesn't need to know the details so much. He or she just need to know the overall context and then can assign accordingly. So the action space is assigning tasks to agents. All right, so each agent will have a different abstraction space that is most performant to that particular agent. Okay, of course, later we talk about memory. All right, today I won't be covering too much about memory, but my core belief is that memory needs to be of multiple abstraction spaces, and the memory can be fed to each agent separately. So what do I mean by multiple abstraction spaces is that, when you look at an image, sometimes you look at the pixels only, sometimes you look at the objects. Like you look at me, you see my face, my shoulders, that's the objects. But you can also look at the pixels like brown, black, and so on. So when are these useful? Okay, when I want you to create an exact replica of me right now, then you look at the pixel level. When I ask you to create a sketch, then maybe you look at objects because you just need to sketch where's my head, where's my shoulders, and so on. So similarly, I think in order to solve arbitrary problems, you need to have arbitrary forms of memory that can do at the micro level, the macro level, and so on. And that will be the future works for TaskGen. We incorporate more and more such memory spaces. So this idea of hierarchical assigning of agents, the idea of different abstraction spaces to solve problems, is a very key insight for TaskGen. All right. And so moving on to the last point, the last slide here is basically the overall thing, where your meta agent has some information and knowledge you want to share to your agents. So it's like typically like what has been done, what is the broad guidance, that kind of things. It can be shared using the we have this thing called subtask completed, that you can share all the subtasks that have been completed from the top to the bottom. Okay, but from the bottom to the top, okay, we don't share everything. We only share a summarized version of what has been done. Okay, so this idea of sharing only what's needed for the agent is a very key part of TaskGen, because we don't want every single component of the system to know everything. In order to have a performance system, each part should only know what it needs to know. And you can configure this using subtask completed. There's also this thing called shared variables, where you can share like it's a dictionary to store information. And each of these components have this thing called global context. You can take some parts of shared variables as context. So this is the idea. If TaskGen, you have like a shared variables global memory that can be shared with anyone, but each agent will only take what they need using the global context. And this makes for a very, very efficient flow of information where agents can share information with one another, but you don't have to take all the information, because not all the information is useful. Now, as you know, if you use LLMs, you put too much information, sometimes they might hallucinate a lot more. Yeah. So it's very important to constrain the amount of things that each agent or each function receives. All right. So I just pause here for a while. Do you have any questions on this slide? Because this is a very important slide as to how TaskGen works.
So
You can
John,
ask now.
so I have a question.
Yes.
What I understand, like the meta agent is supposed to break the task into mutually exclusive subtasks, right?
Yes.
So let's say like there are certain tasks or certain problems like where you cannot probably divide into mutually exclusive subtasks. So in those cases, I mean the subtasks are somewhat related to each other. So in that case, like how this is handled in this agent?
Yep. So if the subtasks are related to one another and cannot be done sequentially, then you will need a function, an equip function that can do this whole chunk together at one go, right? Because if you have, okay, but one thing about this framework is that if you have done one function, like you find out the dishes you want to eat, and then the next function will find out the ingredients based on these dishes. The next function call will actually have access to the earlier things that have been done. They will have the subtask completed, which is actually the action input and the action output. So it's like the function input and the function output will be provided to the later few functions as well. So they can use that as context for their tasks. So there's some sharing on information using subtask completed.
Okay. So in this way, like you are keeping the context for, in the shared variables for different subtasks to, share information between them, right? So
Yeah.
this way, like some hierarchical learning is also there, right?
Correct. So in the shared variables, you can also store learnings between tasks. Like once you have learned that, oh, path A has a snake, you can store that as a reflection in the shared variables. And next time when you do the next task, your global context can reference this kind of reflections, and it will try to avoid doing stuff that yes known to be dangerous. Are you asking about this kind of approach?
Yeah. I mean, multiple subtasks, talking to each other like in a iterative way. Like let's say in a software development environment, like a software development problem where like you write some code and you test it, and it's iterative way. So those two subtasks are not, mutually exclusive. So they have to talk to each other in some way.
Yes. So that will be handled by the agent. So like when the subtask does something, next subtask run, the agent will actually have this subtask completed, have the shared variables. It can actually pass information down to your next few subtasks.
Okay.
So I have a question.
Yes, yeah.
So the subtasks completed, is that your feedback loop?
No, that is actually maybe I go on to the next slide. So the subtask
Oh,
completed
am I ahead of the slides?
is actually something like this. You have your different actions. Like for example, the inner agent will think of 5 dishes, and then the output will be here. So the inputs and outputs are your subtask completed. So as I said, different levels of agents will have different knowledge. The meta agent will not know this very, very specific details. They will only receive a summary from the inner agent saying that, okay, I've done this. I've come up with 5 dishes and their names. So subtask completed is actually different for the inner and the outer agents. And the main reason is because the meta agent does not need to know so much. But the inner agent will have everything here as the subtask completed handed to them, because they need to also have some context about what this meta agent is doing in order to do the next few tasks.
Does that update some type of global state then? Is that what's happening?
Yeah, this subtask.
So that agent, the feedback, well, what I call feedback goes at the global state, and then the agent makes decisions based off that state, right?
Yes, correct. So there are 2 global states. One is a subtask completed. The other is shared variables. Yeah, you can also, in each of your function calls, update the shared variables in what. So you want to like update where the agent is in the maze, what position, what the agent has tried before, the actions. You can put all of this in the shared variables as well.
Right,
So
and that master agent then will make decisions based off that state, whether what functions it calls in the future. Is correct?
Yes, correct. Yeah, so there are different ways to do global memory in TaskGen. Subtask completer is done automatically for you, because when you do your different actions, we can store this action inputs and outputs. Note, we do not use the traditional React method. The React method is thoughts, observations, actions. I realized that actually if you take away the thoughts and observations from the agent and just put actions only, actually it works about the same. And you save a lot of tokens here, because these 2 are very verbose. This is actually all you need. So TaskGen, as much as possible, I've tried to optimize the pipeline to use as few tokens as possible to do the same task. Yeah, so this is comparison with TaskGen and React method. React is not very efficient. Okay, so let me just move on. I think we can discuss more at the end, because I do want to give my collaborators some time to go through their parts as well. Okay, so just a brief idea for those who haven't used TaskGen before. Very easy to use. First, you install TaskGen AI. Then you import your functions here. And then after that, you define your own LLM. So over here, I just want to illustrate, you just need to have a system prompt and a user prompt. You can pass it through an OpenAI API or like Claude or Gemini and so on. You can put your function here. You can do your local LLM here as well. At the end of it, as long as you return an LLM response, and just take note, this must be a string, okay? Because we need to find out where the JSON is from this string using the string find method. So this must be a string. So as long as you adhere to this format, you can interface any LLM with TaskGen. All right. So 3 easy steps to use TaskGen. And how do we use the agent? Okay, very simple also. First up, you want to define your action space. You can define functions like buy tickets, give it the parameters. And if you want to, these are optional. You can give it the types also for your functions and the output type as well. This will be all given to the LLM in a very concise format. Okay, this is the description of your function in the doc string. And just mention the ticket and location, which are the, location and time, which are the variable names. And this will be interpreted by the LLM to fit in those things. So with this in mind, we are able to, interface an agent. So the agent name is this one. The agent name is personal assistant. Your agent description is like what your agent needs to do. And then you assign your LLM. Default, if you don't assign, it will be OpenAI GPT-4o mini, which is very performant with TaskGen. Yeah. So then you assign your functions here, like buy tickets, you assign this function. You can run your agent with your tasks. And then you can see that the agent does things like what's the observation, what's my thoughts, what should I do next, calls the function with the right inputs, and then gets the response here. And then it thinks that, okay, I've bought the tickets, I can end. And just to highlight the difference between TaskGen and other agentic frameworks, we do not reply the user as a subtask. Okay, why is this design decision made? It's because sometimes you want to ask the agent in different ways. Like in your reply user, you can even say, I want to reply in the reply only in bullet form. You can customize the reply in the reply user. So it's very flexible about how you can interface your user to take in what has been done, the subtask completed, to reply the user. So you can see that right now, if you do a reply user, you can see that I've successfully bought tickets and you are all set to enjoy a visit. So this is just a very simple example of how to use an agent. You also notice that this can run in 3 or 4 lines. In fact, if you don't put the function, 2 lines is enough. So as compared to other agentic frameworks, this is super easy to use. And this is intentional because I intend for the agents to be like the basic building blocks like Keras. You can do agent.run, agent.reset. You can interface them in multi-agent settings. You can have groups of agents doing stuff in parallel. We also have async agents, by the way. TaskGen is fully asynchronous if you use async agent. Yeah, and so this basically helps to do a lot of things like in parallel, and you can only imagine the amount of frameworks, the amount of possibilities that you can use this for, because it's meant to be modular. All right. So I will go through this more like as take some questions at the end of it. Okay, I have exceeded my time a little, so I just want to go to the next part. So what's the design philosophies for TaskGen? We want to keep this as concise as possible because we want to use minimal tokens, and also the aim is to reduce cognitive load on each part of the system. Right. Then the second thing is we want to map each subtask to only one equip function because this is called feasibility of actions. We want to make sure that actions are feasible and not like something that cannot be done. All right. So the other kind of guidelines that you should use when you use TaskGen is that you should only call an equip function that is not you should only call an equip function that is not above it in the hierarchy, which means that like you don't call back the agent at the top as much as possible because that will result in cycles. Okay, and you should ensure that each agent has the context and equip functions relevant to its own space. Like the CEO will get stuff that's more macro, maybe the engineer at the bottom will get stuff that's more micro, and so on. So this is very important because the planning abstraction space is based on the context given, is based on the action space given. All this should be unified. Okay. So the last thing that is very, very key also is that we should not share all information with all agents. We should only share what's needed for each agent to make a decision for better performance systems. Okay, and with that, I'm going to move on to the experiments where I'll invite each of the collaborators to just give a brief run through of what they did and like what they found out. So first we have Hardik. Hardik, please.
Thanks, John. So hi, this is Hardik, and yeah, let's talk about agent contribution. John, can you go to the next slide, please? Okay, so I'll start with just the motivations part. Yeah, I mean, as you all know, right? I mean, TaskGen is built in an open source space, and we all believe in the ethos of open source, and community contributions is important for us. I mean, we want TaskGen to be a community-driven ecosystem, and we want to have an environment where you as a developer can build out powerful agents and then contribute those agents for them to be reused and create a diverse marketplace, right? And when you contribute your agent, I mean, it's not just contributing some piece of code. I mean, it will help us improve our TaskGen's functionality and also push the boundaries of what's possible, right? Others can build upon your work, and it just accelerates development across the board. The contributions that you would be making will be made to the main TaskGen repository, and it will have you as an author. So you will come up definitely as a contributor to the TaskGen framework, and which is what we all encourage you for and would be really helpful. So in short, right, I mean, when you use TaskGen framework to build out your powerful agents to solve your work, we want you not to just solve your problem, but also want that it becomes a part of a larger solution, and we all make progress as we go. So having said that, like I would want to walk through like how you can actually do that. So John, can we go to the next slide? Okay. So yeah, I mean, the motivations that I've been speaking about, right, in the last minute, also puts an onus on us to make it as easy as possible for you to contribute to the framework, right? And we also want that the framework should not become a hurdle or should provide you enough support so that you can easily do that. And both the paths under the contribution umbrella, right? Whether you want to contribute your agent or like load a community agent, we have put in significant effort so that it's just like one line of code and you can get done with that. So towards the upper part of the slide, right? I mean, there's a snippet talking about how you can contribute an agent. So you can contribute an agent just from the Jupyter Notebook or any environment where you are working on. This does not need any prerequisite for you to install something, clone something, or anything like that. You can build your agent like you do. And then the last line, my agent.contribute agent is something that will contribute your agent to the GitHub. You can provide some comments, and we encourage you to provide some author comments so that like other people who are looking for similar functionality can search and find your agent. There's one other thing, right? I mean, as the contributions goes to the GitHub, we'll need you to provide your username and a token so that we can authenticate you and tag it with your name. The loading of a community agent, right? I mean, let's say you want to working on a project and you find out agent does something that you need, or like it does a subtask of what you need. You can just load that community agent as well with a single line of code, agent.load community agent, and just pass in the name, and you get all the power of that agent, all the quit functions, all the sub agents, and so on and so forth. So you can essentially get started with one line of code, and that's what we want. John, can you go to the next slide? Yeah, thanks. So yeah, I mean, having said that, like I just wanted to take a minute and talk about the technical aspects a bit as well, just for transparency, as well as to give you some confidence like around the process. So even though like that's like one line of code, there is significant engineering behind the curtain, right? So when you say that like you want to contribute an agent, the framework goes and checks like whether you have a fork of TaskGen already, or if you don't, we'll create it for you. Once you have a fork, we'll generate the Python representation of the agent, which contains all the pieces that your agent is built upon: name, description, again, sub-agents, functions, and so on. Choosing Python has been a deliberate choice because it's very human readable, it's transparent, and any users or reviewer can actually see to a completely like what exactly your agent does. So once we generate the Python presentation for the agent, we use the internals of the Git commits, create trees and all, and commit it to your fork. Now we had to use internals of the Git because we don't want to use Git commit and CLI commands like that, because that needs you to have Git on your laptop. So we went with the internals of the Git and used the APIs directly. Once it's committed to your user, your fork, we initiate a pull request with the TaskGen repository, and you are all set for your contribution. So yeah, I mean, having said that, like I think that was a quick walkthrough of the contribution process. And yeah, we are definitely open for any recommendation or any issues that you face. Yeah. Okay, I think that's on my part. Over to you, John.
Thanks, Hardik. So I'll be recording a session separately with Hardik as to how to load and how to upload and how to download these agents. So this will be very important contributions because it will help to grow this community. If you don't like to use GitHub code, you can also contribute directly your Jupyter Notebook in the contrib folder on TaskGen. So there are different ways to do it. This code will just make it more templatized so that people can just download it. Yeah. So if you have created like maybe an agent to analyze essays, some people might just take it wholesale and use it for their products or use it for their own projects. Yeah, so that's the idea. And let's bear in mind, all this should be free to use and open source, because I'm a strong believer of the open source community. Like ideas only spread and grow once you build them and share them with people. All right. So next, I talked about Maze Navigator, which is an experiment that I did as part of my PhD work. I've actually spent 5 years thinking about how to improve reinforcement learning, because reinforcement learning is very slow to learn. Reward, sometimes you may not get it. Like if you want to talk about a maze like this, if you get a reward only when you reach the door, you might take forever to reach the door, or you may not even reach the door. That's a difficult problem. It's called a sparse exploration problem or sparse reward settings. And this basically hard exploration problems. I mean, yeah, this basically means that a lot of times if you use reinforcement learning, you get no reward at all. You have no learning signal. So I actually created a method called learning fast and slow that tries to do goal-directed learning. Given start state and goal state, try to find the next action to do that reaches the door. So like you can do the action here. So the learning fast and slow is the paper. And this basically you can see in the next slide, okay, that this method solves the 40 by 40 wall about half the time. Okay, so the 40 by 40 maze is very difficult. There's only one small gap in the middle. Okay, and these obstacles will change halfway from vertical to horizontal. So whatever you learn from the start will be completely moot once you reach this. Okay, the agent will have no idea that this has changed. Okay, so before I go to the results, in order to solve this challenging environment, I had to use a planner, okay, for TaskGen. So what this planner is that given the environment state, which is like where the agent is, agent position, goal position, known obstacle position, because the agent has some memory that it can update based on the environment observations. Okay, it's able to come up with a list of steps, which in this case is like move right 7 times, move down 3 times, move left 7 times, something like this. Yeah, these are the list of steps. And this list of steps will actually help the agent, okay, because what the agent will receive, the agent will only execute one step at a time. So the agent will maybe execute this first part here first, execute. Okay, if the step is successful, yes, okay, no, not completed, then we will go back here. Okay, and then we'll go to the next step again, move down 3 times, let the agent execute. And then I've moved left 7 times and so on until the whole plan is done. After that, we will check whether the task is completed. If the task is not completed, this planner will replan the steps again. So this planner is important because it tells the agent what are the next few steps to do. And what the agent would do is the agent will execute these steps one by one, right? So actually a lot of existing web browsing papers, the latest few also use some kind of methodology like that. So I quite like it because LMs in general, if you ask them to think of just the next step only, okay, sometimes it can go left, then it goes right, then go left, then go right. It tends to repeat what they do. So if you have some list of steps here, it will sort of anchor the agent in achieving this plan. All right. So initially this planner was the pre-built in the agent itself, but I isolated it. Okay, what I realized is that if you ask the agent to follow a list of steps, the problem with following a list of steps, okay, the pros is that continuity of plan. Okay, the cons is that if something goes wrong, okay, the agent might still blindly follow plan. So I kind of want to decouple this planner with the agent because in some cases, you don't need a plan. Like you want to do a creative poem, you just need to do one step at a time and so on. You don't really need this planner for a list of steps. But in some situations, you might need this list of steps. So just for information, this planner is not out in the TaskGen yet. I'm still refining it, but it should be out soon. There will be a planner module that can wrap over the agent, right? So this is just the idea of how this was done for this experiment. This planner is absolutely critical for this maze because if not, the agent might do stuff like this. It might reach here, come down here, then come up here again, So this is something that like the plan would help to solve. So what are the results? Using TaskGen with the planner, I gave some few short examples of how to do it. It managed to solve the 40 by 40 very challenging environment all the time. And in comparison, the prior methods that I did, like fast and slow, solve about half the time. And like PPO, proximal policy optimization, one of the state of the art for this kind of navigation tasks, like it only solves it about 10% of the time. So you can see these are the RL methods, reinforcement learning methods are here. Are not good for sparse rewards. Yeah, it doesn't learn very well, and especially for changing environments. But if you look here, these are the goal-directed methods, goal-directed, memory-based methods, like TaskGen, are better. Yeah, so this is the key conclusion that you find out. And I mean, there are other stuff also, you could see like how good it is compared to optimal. And actually, it's not too bad because of the way that like the planner looks ahead and stuff like that. Like even when it reaches the obstacle, it's able to trigger a change in plan and adapt. And this means that like the amount of steps taken actually is very, very close to optimal. Close to optimal because of dynamic replanning. So TaskGen allows for this because whenever you see something that doesn't fit, you can trigger the planner to replan again. Yeah. So as you see in the previous slide, you are able to use the planner to wrap over the agent to do this complicated workflow. And this is the beauty of TaskGen because given a very, very modular agent, you can wrap your own frameworks, your own architecture around it. So this is just an example of how this can be done. All right. I'll take questions of this later at the end because I'm going to move on to the next presenter. Brian, you can take over now.
Hi, hello everybody. So I guess I'll just be presenting on web browsing agents. So this next screen. So what is the whole point of this web browsing agent is basically to have an agent that is a web navigator to basically serve the web for you. And you can see, I'm not sure if the photo is very clear, but you can see that the action space includes things like informational search, navigational search, visit page, open browser, close browser, and summarize content. So it's a very simple a MVP kind of like of how apps like Perplexity sort of just works behind the scenes. It's not very refined, but if you can take the code and you play around with it a bit more, it basically can become a product like that. And I there's a link to the code implementation, but basically it's just on the TaskGen repo under contrib. Okay, then next slide. And basically under the test, as you can see from tests, there's some queries that don't work as well as others. I guess it's just really a ChatGPT thing, or I mean like a large language model thing. But as you can see that there are queries that work really well and they work mostly 100% of the time. So, and we'll go on the next. And yeah, I guess I can do a demo and I'll share a screen and you can go through that. Let's see. Yep. Oh, can everybody see my screen?
Yeah, all good.
Okay. So let me see. Okay. So for how I use this, basically it's a script inside the TaskGen repo, as I said before, under paper web browsing agent, and it's here. So how I run it is basically just use Python TaskGen meta agent. It's a different file name because I'm not running from this one. I'm a bit too lazy to install the venv. But all you have to do is just Python and then the file name, and it brings you to this kind of like a CLI template. And so what you can do is say you can ask it a question like open browser, search recent AI developments, and summarize relevant content. And then it should just open a browser. Give it a second. And then it will take some time. And okay, so as you can see, basically what it does behind the scenes, it says the first step is to complete the assigned task to open the browser, and then it allows you to perform the subsequent search, and then performs the search with the informational search parameter that I placed in the code around here, and it basically uses a library called Helium to run the search and open the browser. And next it summarizes the content. So once it summarizes the content, and then it returns the actual usually it gives a bit more, but because I didn't write an explicit function for it to tell us the content, but actually it gave a summarized content based on something like this. And what's cool about using TaskGen to do web browsing is basically you can even ask it a more controversial thing like who's the Donald Trump shooter. I probably won't run this right now because it takes some time. But people on Twitter, X, they've been saying, oh, how come I can't use ChatGPT to ask these kind of questions? But basically you can use this for TaskGen. Maybe I should run it actually.
Sure. Go ahead if you want to.
Yeah. So, open the browser, search, summarize the relevant content.
Yeah, so you can see the task that we created for this, that Brian created for the web browsing is not like curated or what. He just thought of like whatever he wants to do and tried to use TaskGen with some functions to do it. Yeah, it turned out pretty well. Just a plug and play of the functions.
Okay, I guess it's done here. So as we can see from the context, and basically it said that all related news, Thomas Matthew Crook, something. And this is something that if you ask ChatGPT, it probably be like, you won't want to answer you. But because we're taking information from the web, open browser, search for Donald Trump shooter, and you perform the search to get the context from the search, and you get this agent output. And I didn't write any specific function for the agent output. This is something that TaskGen innately understands and does by itself. So it says, so Donald Trump attempted to shoot, and you get your answer. So I think that if you want to build something like Perplexity, something as an MVP, you want to build a really cool web browsing or anything you can think of. This is a very easy tool to quickly get started with. As you can see from the code, it's really short. It's really readable. There's not too much things to think about. And because TaskGen really thinks it out for you. Oh wait, sorry, it's this one. But it really thinks it out for you. So yeah, give it a try. And I guess this is it for my demonstration.
Thanks so much, Brian. Yeah, this by the way, to get to this level wasn't easy. It took about 2 months of prompt engineering, trying out different styles. In the initial version of the web agent, if you've seen our previous version of the video, didn't work too well. But after lots of iterations, now it's finally of a decent standard. And of course, if you have your own project, you try it out. If it passes, it's good. If it fails, just feedback to us. We can improve it together. I intend for this to be continually developed with more and more features. You can check my other videos for like my vision for my 10-year plan and so on. This will be all done on TaskGen itself. So you can stay tuned for more updates. Okay, so next we have Richard. All right, Richard, you can take this escape room solving in TextWorld.
Excellent. Okay, so if you just go on to the next slide and so this is a bit of a busy slide trying to get across what's going on. So text-based adventures, or also known as interactive fiction, is a genre of computer game from the late 70s and 80s and so on. The reason they're text-based is because they predate graphical user interfaces by some distance. And it's the associated archetypal work is Zork, which it is, which was loosely related to Dungeons and Dragons around the same time, and not by accident. So the Zork, for instance, the computer takes on the role of being a fairly sarcastic and unpleasant game master running a game where you're exploring dungeons and things. In TextWorld, they took those foundational pieces. Microsoft did a paper on TextWorld and building a OpenAI Gym interface for arbitrary creation and execution of these TextWorld kind of interactive fiction style problems. They generally, in the simple example that they use as their benchmark, and I've used to test this, you have to go through a sort of fictional house, find a carrot in the garden, and figure out how to cook it. That's success in this story. However, they can be in any kind of fictional genre you can imagine, and probably someone's already given it a go. In this, so the basic TextWorld game is a game state. You get told you can see this, then it's up to the player to figure out what the commands are. They are not necessarily provided. They're not necessarily knowable ahead of time. And also, given these were made in the 70s and 80s, the programming underneath them is not necessarily consistent either. So that's the kind of challenge you need to enjoy. It's similar to John was saying, this 40 by 40 dynamic maze. These can be dynamic worlds that will change and they respond and so on. However, in these examples we're using at the moment, or I've used for this paper as a demonstration, the worlds don't change independently of the player's actions. But that wouldn't necessarily change very much. You can go to the next slide, please, John. So TaskGen as a player interprets the descriptions given, creates novel commands, remembers past actions, strategically navigates the game world, and it's able to discover appropriate objectives without guidance. So again, one of the elements of this genre of computer game is exploration and discovery. Right? And in the reason Zork's in the Library of Congress, it's because it really set out these adventure game tropes that have been followed ever since, as recently as any computer game you can think, any open world computer game you can think of these days. In terms of attempting these games as a player, you need to remember, and it's quite common to have pencil and paper and make notes, draw maps as you go, because they can be very large and very complex. And they are designed to have puzzles in them. So TaskGen uses persistent memory to remember game objectives, the commands that have actually worked, as well as the objects and rooms encountered while playing this through each game. The conversational context in the particular flavor of TaskGen that I'm using is the conversation class. It generates an ongoing summary of the history so far. That proved to be extremely useful when essentially the player got itself into a dead end. It would discover, this isn't working, I need to go and do something else. Right? Really helpful, totally essential. Can you go on to the next slide, please, John? So in the end, did it work? Yes, the test was not exhaustive because these are some of the games are the size, good sized novels, and that's just a very expensive proposition to test them out in that regard. Also, there's no open benchmark to compare them to. So I just use the relatively simple introductory samples from the TextWorld project. And so I can compare behavior versus their historical norms. And TaskGen and even plain GPT-4 does very well. But TaskGen beats it by 30% using the same LLM on the same problem. One of the features of TextWorld is the ability to offer less feedback, sparse or dense feedback about how you're doing, John alluded to earlier with his maze, and also to offer more or less information about the world in terms of these are the available commands. So the simplest possible agent, it just chooses randomly from the available commands, and actually for simple problems it'll get through some of the time. Well done. But without that, then you need to imagine what the commands might be, and you may need to come up with new commands that are appropriate for the context, because they're often object manipulation commands, and not all objects are in all rooms. And not all rooms connect to all other rooms. So you need to find your way and find the objects and so on. And so the reason I find this a useful and relevant test is actually it simulates many human activities in a knowledge worker environment, the application of policy to situations and so on. And I think that's similar to where Symbion's going with their own product, I'm sure.
And now we have Bharat to go through with us how to use TaskGen to solve the challenging math dataset.
Thanks, Sean, for this opportunity. So in this section, we will talk about like how will we use TaskGen agents to solve the math problems. Can you move to the next slide? Yeah. So in the normal cases, using an LLM to solve like math problem is a challenging task because LLM itself doesn't have abilities to solve complex mathematical problems. So uh, basically what you can do is you can imbue these LLM with the capability of like some functions like code generation or debugging and so on. Now with TaskGen, it's very easy to do this. So in this particular slide, we are basically presenting the TaskGen agent, which is basically a math problem solver. So if you see, there's two parts to it. One is an agent without functions. There is no functions given to it. The other is when we imbue the function ability to this agent. So in the normal case, when there is no functions, you see like in the left part, the problem statement is given and we'll just ask LLM to solve this problem. And there is no functional ability at this point because the agent is not equipped with any functions. In the second part, what we do is we equip the agent with two functions mainly. One is the code generator and another is the code debugger. Now, how these will help us to solve these problems? So when we basically ask LLM to solve a particular problem given this mathematical problem statement, it will first choose whether it will use the code generation ability of the agent or not. Now, if it chooses the code generation ability of agent, what it will do is it will first generate the code. So if you see in the bottom left, there is a code generated for this problem statement by the LLM or the TaskGen agent itself. Now, what it will do is like it will use this code and it will run the code and get the results. Now, if there is any error in the code also, there is another function which is called code debugger, which will take that error and basically retry or regenerate the code again, solving that particular error in the code. And this will happen 3 times. Now, if it doesn't basically give you the correct code in 3 times, then we fail that particular problem. So that's how both the system works. One is with agent without function and one is the agent with functions. So now if we go to the next slide, we will talk about the data set and the accuracies more. Okay, so for this particular section, we mainly used a math data set, which is one of the benchmarking data set which people use on the math problems. And we specifically choose the most difficult problems from this data set, which is the level 5 problems, which is the most difficult from that. And we specifically basically choose the test set because from our understanding, normally the train set of these data set are already exposed to LLM, so it's not a good idea to use the train set or the well set for evaluation purposes. So we use the test set and we basically use 5 categories and 20 problems each of these category. And this is also a randomly selected problem, so we don't actually cherry pick these problems, it's randomly selected. And total we have 100 problems. Now, if you see here, there is 2 bars. One is agent with functions, which has this ability of code generation and debugging. One is agent without function, which doesn't have any ability of code generations. So if you see the performance here, specifically in the categories of algebra, where you normally require some type of mathematical tools to help you solve that particular problem, you see the accuracy without functions is very, very low. Like for example, in the intermediate algebra, we get like 12% with functions ability and we only get 4% without functions ability. So same for counting and probability also. With the help of these code generation and debugging capabilities, we see a really good performance boost here. So in overall sense, if you imbue TaskGen agent with a particular functionality like code generator or debugger, you will see that you will be able to solve these challenging mathematical problems easily. Now, more can be done here, like you can give it external knowledge base about some lemma or like related to that particular problem, but we didn't actually explore that part here. But we hope that that will also increase or boost the performance to higher numbers. So yeah, so in this section, we basically wanted to see whether we can use TaskGen agents on the math dataset and solve these challenging level 5 problems. And we basically found that, yeah, if we equip the TaskGen agent with the correct function abilities like code generation and debugging, we'll be able to solve them in a very good manner. So yeah, I'll hand over to John again.
Thanks, Bharat. And now we shall invite Prince to talk about RAG over the NaturalQuestions dataset.
Perfect. Yeah, hey, this is Prince. So yeah, this experiment is just, extending on the previous slide, which John was saying, usability or, advantages of using TaskGen functions in your normal like math problem you have used. Here on RAG, we can use the same thing. So can you go to next slide, Bijan? Yeah, so just a brief overview of RAG. RAG stands for Retrieval Augmented Generation. So there basically you, if I have to describe it, using GPT and the very non-interactive way, which is, most flows and most people use it in a way is, you have an LLM and you have some vector DB and you have some query. You provide that query to vector DB and find top k matches from vector DB and provide that top k entries as a context to LLM and get your answer. So that's a non-interactive based retrieval, which these days almost everyone uses. What we are doing here is interactive retrieval using TaskGen agents and functions. So as soon as this example, you have one user agent and two functions: context fetch function and answer function. And the context fetch function is assigned with an external function which actually interacts with vector DB. So you can think of context fetch function can query vector DB to get top k given some query. So what happens is I did not use any kind of for loop, nothing else. I just instructed user agent. Okay, now you have two powers, two things. You have answer function, you have context fetch function. If you find answer, good, reply to the user. If you don't find answer, fetch more context. And it's very common, right, that you have a big database in vector DB, and you may not find your answer in the first top 10 results, and you may find in the third top 10 results, and you may think I will include all 30 context in one go, but that's a problem, right? Problem both in case with big contexts, LLMs performance degrade, as well as cost also, latency also, so everything. So that is not an option. So we go to the next slide. I'll describe you the exact things that happens. So for example, here, so when a user submits a query to user agent, so the user agent will invoke context fetch function with the initial query and starting batch number 0, and just to fetch top 10 first batch 10 results. So with the context obtained, the user agent then delegates now answer function, it's your responsibility. Now you have the context, answer it. And if the answer if the context is sufficient to answer this question, a response will be generated and user agent will respond to the user. If not, then answer agent will signify that I don't find any answer via no answer string. And then if no answer is received, then user agent understands the answer function is not able to do that. So what should I do? I should go to context fetch function to get more context. And this is kind of iterative process, but there is no code written for iterative process. It's all orchestrated directly by LLM, and this is a very simple workflow which we are demonstrating, but you can think of it as a very complex workflow. You give a agent set of things that it can do, and you can condition it. If this happens in the prompt, then do that, otherwise do that. So it can do everything in a sequential manner. I think there was also one query about software development tasks where there are multiple subtasks and you want to do something if something happens. So this is similar to that. So here it checks answer function. If it succeeds, then good. If not, then it will again reinvoke context fetch function dynamically with no code at all, just TaskGen. Can you go to the next slide, John? So yeah, these are the results. So what happens is the non-interactive retrieval that I explained in the beginning, using GPT plus vector DB, and the interactive retrieval via TaskGen. So we have some numbers that signify the improvements over non-interactive retrieval. So you get your F1 score increase, precision, and this is all if I have not code present here, but you can think of it. It's around 20 to 25 lines of code that did this magic. Nothing fancy. It's just that if you want to make a more complex system, you can actually make it way better performance. So that's what the power of TaskGen. In 25 lines, you can do magic. That's it from my side, John.
Thanks, Prince. So I think that's more or less the end for the presentation. And the main thing that we want to say is TaskGen is a collaborative thing. It will be open source forever. And the main thing is to build towards fast learning and adaptable agents. So a lot of future works in place, like imbuing planning, imbuing multiple forms of memory. Like just this week, Prince and I were doing ChromaDB memory interfacing, and there's a lot more to come. I'm intending to include knowledge graphs and so on. And there's really a lot of potential for this, because if you imbue more forms of memory, more different types of architectures, or even just imbuing more functions itself, it can solve a lot more problems. Okay, so your agent is only as capable as its action space, or like as its memory space and so on. So in order to help us grow and help people develop this framework more, the easiest thing to do is to go to the GitHub and start it, and use it for yourself. Don't just start it, use it for yourself. I mean, there's no point just talking about it. Actually use it and see whether it works for you. For all our experiments, you can go to the contrib folder. Go to the paper folder. You can see the code for all our experiments there. So it's all open source. And actually, before we move on to questions, my professor, Mehul Motani, is here right now. So I just want to invite him to talk a few words about the equation game. Prof. Mehul, please. Are you there?
Yeah. Sorry. Hang on. Yeah, sorry. I was somebody just knocked at my door when you were asking what did you say, John?
Oh yeah, you want to say a few words about this idea that you have, and
Yeah, I can. Hi, everyone. It's the first time I'm meeting many of you. So my name is Mehul Matani. I'm a prof here at NUS, and in fact, John and I are working together. John's a PhD student who is, just submitted his thesis. So yay, John. But so I had this idea. So I'll tell you the story of how this came about. So last week I had this idea of so the way I teach is I use a Socratic method. If you're ever in my classes, you will find that if you ask me a question, I will never tell you the answer. What I will do is I will ask you more questions and help you figure, and help you learn to ask questions so you can figure out the answer. And what I wanted to do was I wanted to get an LLM to do the same thing. And LLM essentially, if you ask any of these LLMs, the answer like some of the stuff that Bharat was doing or any of the other things, the LLM just gives you the answer, right? I think for example, Brian, if you ask an LLM who shot Donald Trump, it will just tell you it was something like crooks or something, right? So, but I wanted to see if we could build a system, an LLM that built on TaskGen that doesn't do that. And in talking with one of my PhD students, Kason and John, we came up with this simple prototype called Guess the Equation. Is to help students learn about the functional structure of mathematical equations. So what the program does is it gives you some data. It asks you to guess what the data is. It plots the data, and if you got it wrong, it tells you some like suggestions. Like for example, in this case, the answer is actually I don't know what it is. Y equals X.
I think it's 5x. Y
equals X. I think this is Y equals X. But you put in Y equals 2X, right? It kind of does this, and it tells you to think about. So of course the agent response is a bit stochastic, right? But it like I've run this many times, and sometimes it will ask you to think about slope, y-intercept, and so on, and it kind of encourages you to head towards the answer, and I really like it because often many times in education you're discouraged from being wrong, but actually that's how you learn by being wrong, and I call it productive struggle. And so I feel like this kind of system where you have these agents respond, talking to an LLM, also talking to the user, can facilitate this productive struggle. Yeah, I mean yeah. I mean we're still working on it. I'm right now. I think and to show you that TaskGen is really neat and compact. I think John coded this up like in a day or two. Yeah, I mean, I talked to him about the ideas and what to do, and I think I was really impressed, right? Like over the weekend, he messaged me, says, "I have something." I was like, amazing. Yeah. So I think TaskGen is onto something. I'm happy to answer questions about at least the high level about this. Like, there's no a code here, but I have a couple of questions for the other folks, John, if that's okay.
Yeah, sure. So with that in mind, we can proceed to the Q&A for the questions. Maybe let me just put to this slide because it's the most representative slide for TaskGen. And yeah, happy to take questions. Prof, you can ask first if
Yeah, so I think the broad question I have, and I think the most exciting stuff, I mean, of course, what you've done is exciting, but I like the what you talked about, these additional agents like planning and so on, and I think especially for the maze world, I think it's worth saying, and maybe I misunderstand, but a lot has to go into that planning agent, right? That planning agent requires care, right? I mean, you showed amazing results, but I think the planning agent was doing something interesting there. That's why it got to 100%, right? And I think you might want to say, if you could say something about why fast and slow only got to around 50-60%, but the TaskGen agent got to 100%. I think it's the magic is in the planner, right?
Yeah, more than the planner helps to make the LLM more consistent, but more than that, you know, because the fast and slow is a neural network based method where it just takes in, you know, inputs of the form of like the agent's X and Y position, the goal position X and Y, and in between there is just doing a softmax to choose the action.
Yeah.
It has no idea of it being a grid world. It has no idea of the agent can only move up, down, left, right. To the fast and slow agent, the actions are just numbers like action 1, 2, 3, 4.
Okay.
But for the TaskGen agent, because it's using language as the semantic layer, it's able to know like, okay, I'm going right is an increase in the x-axis, going up, down, left, right, and the spatial orientation of the maze, you know, like, so it's able to take in more information in the description, and that's why I think LLM agents in general will be more powerful as the overall architecture in a planning system. Because you can learn much faster if you can already do semantic matching. Like if I say I want to go to the fridge to eat stuff, you know, you don't have to say that moving my left leg is action 1, moving right leg action 2. You know, I don't have to do that. I can just say you move there. I mean, that can be a semantic action.
Yeah.
And
I see.
at the lower level, you can use reinforcement learning. But you know, this shows that using LLM as the top layer, like over modular actions, and the modular actions could be learned by reinforcement learning. I think this is the way.
So is this the same argument that, for example, that paper the Ghost in the Machine makes about playing Minecraft?
Yes, Ghost in the Machine also uses an LLM as the semantic layer to plan the actions. Same as Voyager. So I think these are the better approaches.
Yeah, I mean, let other people also ask questions, but I have specific questions for each of the presenters, but let me not dominate. Yeah. So,
thanks, Prof. Mehul.
Yeah.
Next up, we have a question in the chat from Vernis. Do you want to say the question out yourself, or shall I say the question for you?
Yeah, no worries. I can say it. So basically, I saw lots of different simulations, and like Minecraft included, what you just mentioned. But Richard, it's more to you.
Sure.
I don't really get how you solve latency. Like, how does it learn, and then how does it perform? As well as I'm very interested in the consumption of tokens. Like, for example, from not knowing.
These are great questions, and this is not fast, right? So these are turn-based, text-based systems. So latency was not a concern of mine. Even in the way that I implemented it, it was lazy by me as a programmer, and it was inefficient in the time it took to. So this is one of those things you sit at running and go make a coffee and come back and see what happened, right? In terms of efficiency, I'll be honest with this. It was I haven't seen the tab, but I'm glad I didn't have to pay it out of my own pocket. So it was not super efficient. But I mean, I sort of alluded to that. What I would like to do, and I'm thinking of this afternoon, is I'll set up a local LLM and see how it goes, because my graphics card will run, you know, sort of got 10 gigs of RAM, so about 10 billion parameter model after quantization locally. And
so
in principle, that should run, right? So then I can have a crack at Zork itself, because TextWorld has a pretty good library of all these old games included.
Yeah. So the second part that I was more interested about is that you have already insanely good performing ML models, and I understand you are not aiming to rival them, like the ones that are playing competitive Dota or StarCraft.
No. That's not the goal for me at all. No.
Yeah,
and in terms of how to do that, you'd have to, as touched on earlier, it'd be like a Voyager goes to the machine style middle layer. You'd need, I mean, there are some really like my own thoughts around how that works is these are really good. The reason I picked out text-based adventures is because I didn't need another layer. I didn't need to build an agent to offer up these are your possible commands. It just is, it's already there. It's all semantic. So that's why I chose this as the problem to dive into. It threw up some other problems, like it's very easy to make the whole thing crash in a heap if you give it a long command because there's no buffer checking because it was written in the 70s. But the that was the reason why a text-based adventure game was chosen, was so I don't need to go and build any other control.
And
I want
if I'm sorry, just a quick question. So Richard, for the end goal is just to test the TaskGen and see how it performs, is it? Like Wizard understands the world, right? Like Wizard can make decisions. In
this case, it was it was largely fun, right? It was but what it demonstrated was really interesting was to watch it fail, right? As you were saying earlier, you learn by your failures, and watching this one fail was really instructive. So in the one of the TextWorld sample randomly generated things, you got to cook this carrot. I've spent so much time looking at this thing not cook a carrot, right? So you dig it up out of the backyard, and it's like 20 steps or something you've got to complete. One of them is pick up the carrot out of the ground and then take it inside the kitchen and cook it on the stove. But on the way, you will find there's a barbecue, and the instruction is you need to grill a carrot. And obviously, everyone tries to grill the carrot on the barbecue, but it doesn't say the barbecue doesn't work. It says it's unstable. It gives you this really bad feedback about what's going on. And so it'll loop around a lot trying to fix the barbecue, because that seems like the obvious thing to do. And what it needs to do is not do that. It needs to keep walking and look for another solution. And so eventually it'll walk inside and find the stove and put it on the stove and it cooks it. And bing, you've won. You've got all the 10 possible points and success.
Yeah. Can I follow up on Bernie's question, which is about your goal?
Yeah, thank you.
I was just curious. So you wanted to test out TaskGen, but in the light of what Hardik said about contributing agents, I was thinking, like, would an agent like this be good, for example, if I want to play but I don't have a player? Like, could I, for example, have this guy be a player with me?
Yeah. So there's
like I think that might be a good use case for this.
In some, I mean, this style of game is very much a one-player business, right? There's not even it's challenge response is the model. So there were multiple. I'm showing my age a little bit here, but there was a multi-user dungeons, MUDs were a thing when I was at university, going back a while. And they were a character-based top-down map. The classic one's called NetHack or Rogue or some version of that. And there were multiple player versions of them, and they were some of the earliest multiplayer games, really. And then if you're of a certain era, you might even remember play-by-mail games where you'd post things in, and they'd once a week, once a month, or whatever it was, and they'd process all the players' actions through some 386, someone sitting on the desk somewhere, and it'd cough up and here's the outcome of everyone's actions, right? So these were some of the very earliest multiplayer games, really. Yeah. And in terms of these, they're interactive fiction, so there is implicitly a reader, right? It's for the reader rather than a multiplayer environment.
Okay. Great. Yeah. Thanks, Richard.
Sure.
Yeah, Brits, you wanted to add on something? Do you still want to do it?
Yeah, I was just saying on that latency point. So, I mean, this issue of, very time-consuming thing actually also. So I work at Symbian. So we were also building, very, very, very complex workflow where, a lot of planning, a lot of action taking is involved. And we came across, these latency issues, that it is taking hell lot of time for any usability perspective, then actually this idea of async came into the picture. So if you see all the LLM calls, whether you use any kind of LLM, they are all HTTP based, right? IO based, and as soon as you see IO based, you can optimize it. Your resources are not being utilized if you are not using async properly for a long running HTTP based communication. So in TaskGen, we actually developed async agent, async function, almost everything async. So that led to a huge performance gain. I think in Notebook also, if you see, there are some places where we have compared sync versus async, and you will run the sync version. It would take around 4 minutes time, and then the same code just in async fashion, it will take you around 10 seconds. So 4 minutes to 10 seconds. That's the thing we are talking about if used correctly. So because the most time consumption, if you see, in case of LLM, is just waiting for the response to come. So we don't have to wait, right? We can do a lot of things in parallel if your system allows that. So that's it. That's what I wanted to add.
I also want to emphasize on the latency part. While it might be slow right now, the idea of testing TaskGen on this TextWorld, in fact, I want to host an escape room competition to use TaskGen to solve as well. It's actually not so much to do the fastest possible system, but more of like if we imbue it with different things like memory, self-learning, and so on, can it solve complicated tasks? And that's the main thing, because that mimics the real world. Okay, TextWorld is not exactly mimics the real world, like the stove and the carrot. Yep.
And I'd say really it is not a real world simulation. And I put absolutely zero effort into making this go faster. So there was that was I considered it at one point and then realized that that's not going to make me any happier. I don't want it to go faster. I don't particularly care if it goes fast. So it's built to be easy to build and easy to understand for me. But if you want to go faster, well, we can talk about that. My consulting rates are very reasonable. But no, there's plenty to do to make it go faster if you want.
Actually, can I just say bye to everyone? It was really nice to meet you all. It was fantastic meeting you. Thank you, John. I'm really sorry to leave. It's just I have a 12 o'clock meeting.
Thanks, bro.
Yeah. So I don't want to be late. Late for that. Yeah. So I'll synchronize with all of you and with you, John, later. Thanks. Bye-bye.
Sure. Bye.
Thank you. Just a quick addition to what we've just discussed in terms of latency. So with what we understood, like TaskGen can actually do the sequences, right? And what I saw since 2017, I was looking at this space, right, of how workflows work and all. So once you know the perfect workflow for a given use case, you can just queue things. So like, yes, LLM can create those queues and those options for different scenarios. And I think that's where TaskGen and similar agentic frameworks will shine. Yeah, thanks.
Yeah, so I would like to also say that's a very good point. I also think that using TaskGen natively as in agentic end-to-end is not the end solution. For those paths that are already fixed workflows, like for example, if you are extracting entities from a text, you can just use an LLM call to do that without an agent. You should just use the LLM call or like the code or rule-based functions to do that, because the less stuff you rely on the agent, the better, the more reliable. And so the agent should only be used for tasks. Like for example, this TextWorld, you don't know beforehand what you need to do because the environment is changing, dynamic stuff. So really this TextWorld is really meant just to see whether it can solve like a sequence of steps. And I was quite pleased that it could solve it because it's a proof of concept. With LLMs becoming faster and faster with lower cost and less latency, we can even interface more agents solving the agent at the same time. Parallel solving, you could simulate lots of different runs and share information with one another. It's like a swarm intelligence kind of thing. So this kind of things will be possible in the next 2 to 3 years. So there's a lot of things that could be possible once the latency goes down. Yeah, so I wouldn't worry too much about latency right now. Yeah, but for actual production systems right now, decouple as much as possible from the agent for faster latency. That's my advice. Okay, I'll do another session on this to share more insights on this. Yeah, but Vanessa, I hope that answered more or less your concerns. Yep. Okay, so I will move on to the next question. Swana, you want to ask me or I read for you the question?
Yeah, I was just asking like, how are you identifying the subtasks for a given task? So is it just by prompting the LLM? So if yes, then probably in many cases the like the LLMs can spit out wrong set of subtasks or maybe invalid subtasks. So in that case, like how are you handling the failure scenario? Is it by using memory or some iterative way?
Yeah. So in this case, to get the next subtask, without the planner, what the agent would do is it will see what it has done before, the subtask completed, the actions, inputs, and outputs. It will see the global context that it has, like what are the, like maybe if it's a maze navigator agent, where it is right now, what obstacles you have seen. So this global context can be fed in. And then based on that, the available list of functions as well, it will then choose the next function to do. Okay, and this, as you said, it might be wrong, it might choose wrongly. And when it does something like wrongly, like goes further from the goal, like it goes further from the endpoint, what it can do is it can see its next position and it can correct itself. It can know, hey, I'm moving too far from the goal, I should move back again. So it's okay to make mistakes as long as it's not a fatal one that leads to like the end of the run or something. It can actually correct itself. Like, with the web browsing, if it searches a wrong site, it can actually search the right site again based on the knowledge of it having searched something wrongly. Yeah, so this is something that this is what I call iterative solving. Like you don't solve the problem from the start to the end like fully at one go. As you try to solve the problem, you realize things are going wrong. The agent is able to correct itself and head towards the right path. And I think this is a very important learning feature, more so than coming out with a list of steps, because the environment is not static. It will change. And I want the agent to be able to dynamically adapt and react accordingly. So so far I'm pleased with the way TaskGen handles it with the subtask completed, global context and memory and so on.
Okay.
Yeah, don't worry, we'll implement your reflection memory soon. Yeah, that's one of the pipelines. So as the agent does tasks, it should be able to reflect and come up with some learnings which it can use. I think this is very important for a self-learning agent. So that will be in TaskGen soon. Okay, cool. Next we have MOE or Mo. Do you want to say your question?
Yeah, it's a question for Prince.
Sorry, it's a little soft.
Hold on. Can you hear me?
Yes,
Yes,
can hear you now.
yes.
All right. Sorry about that. Yeah, it's a question for Prince. So you got a user agent and context retriever agent, right, in your system?
Yes.
Yeah, and user agent basically grades the context retrieve from context retriever, right? Is that
Actually,
correct?
no. So I have replied also. So the thing is, user agent is here not doing much. It is more of a orchestrator than
Yeah.
to. It's not a judge. So it after context is fetched. So user agent just in this case re-ranks it just in a possible manner, in the best manner, but it does not never does that rejects any context. It just passes it through to the answer function. And answer function is is prompted that you have to factually answer the question using the context provided to you. If you're not able to answer this question, then just say no, no answer, or don't return anything. And user agent, since it is seeing everything, right? It is also seeing context fetch function output and answer function output. So it sees that answer function was not able to answer it using the context. So it takes a decision that, okay, I need to fetch more context because this context was not sufficient to answer the question.
Gotcha.
So actually
Gotcha.
we delegate it to the later part, that whether you are able to or not.
Okay. Thank you.
All right, so we have I think time for one last question if anyone has before we end today's session. Anyone else wants to ask anything?
Yeah, I'll go ahead and ask mine. I think it's more of a Hardik question, but I guess we can ask everyone. It's in concern to the contribute agent function, because I got a little excited about that. In the future, once we start doing more work on the planning module, will it be possible to like say, I have a planning system that I really like to use for a specific agent, for a specific task or whatever? Will it be possible to kind of contribute the agent through that function with the planning system as well as part of the agent and integrate it that way, if that makes sense?
Yeah, I think this one Hardik may not be able to answer yet because we haven't created the planner module per se. Maybe I can
Okay.
help to answer this, but like as long as it's something that the code can be obtained from, like for example, memory, we know what's your type of memory and like what kind of LLM you're using and so on. We can put that in the code. So for the planner wise, if we know like your function that you're going to use, and your function must be able to be like translatable into code, because some functions are not, like, then it can be contributed.
Okay, I get what you're doing. So as long as it's able to interface with the other modules and work within the framework, it should be able to.
Correct. So actually what I intend for the planner module to be is like it should be in-house in the agent right now. I will let you define like what is the prompt you want to generate a list of steps. Then basically from that prompt, you can customize it, or you can equip your own functions to do the planning. Like if you want to do Monte Carlo tree search, you can do it there also. The problem is if you do your own in-house functions, we may not be able to pass it out into code. Yeah, so I think there'll be some limited way to share it. But if you really want to share it, you can just do your own commit with everything that that you can share your entire planning function. Yeah, so I think that it's still possible.
Okay, I see what you mean. So it wouldn't be under contribute agent. I would do like a normal commit, like
Yeah,
to the
you can just
GitHub.
commit to the contrib section with your planner.
Okay, nice.
Yeah, or you can contribute the whole Jupyter notebook with the planning overlay with the agent.
Understood. Alrighty, appreciate it.
Yeah, Hardik, you want to say anything else about this this contribute agent, since this is your part?
Yeah, I mean, I'll just add, right? I mean, so in general, right, whatever new features like come in, or like any new module come in, we'll try our best to make it as streamlined for you as possible. So yeah, I mean, whenever the planner module comes in, and I think we'll definitely have a talk and see like how we can integrate that.
Yeah, so I also have a question. So recently, I think we've seen OpenAI, they released what's that thing called again? That
Structured API, the structured output.
Yes, the structured outputs. So actually, I was just thinking, because it would be good to have a benchmark for StrictJSON versus something like OpenAI structured output, right? Because OpenAI, they say they have 100%, but if StrictJSON has 100% on all LLM frameworks, then there's not, it's it makes more sense for TaskGen to run on StrictJSON more than, instead of every LLM they have their own every different LLM provider have their own kind of like a structure output. If structure outputs from them gets 100% and StrictJSON does not, then it wouldn't make more sense for TaskGen to use theirs instead.
Yeah. So this one, I leave it to it's open to change in the future. I mean, in the future, if YAML becomes better, it might even be strict YAML and so on. But for now, we are sticking to StrictJSON, because StrictJSON is more compatible with any LM. Like
Yes.
the structure output is only for GPTs, and in fact, they're using JSON schema, which is like about more than twice the tokens compared to the StrictJSON schema. So as much as possible, I still prefer StrictJSON, but I'm open to change if there's some evidence that the other method works better.
Yeah, I mean, because GPT says it's 100%, so but we don't have that for StrictJSON.
Yeah, StrictJSON is definitely not going to be 100%, because complex ones will be a bit tougher, as it is a prompt-based method.
Okay.
Yep. Anyway, I haven't done any benchmarks for StrictJSON, so if you are interested to help to do the benchmark, please approach me. Yeah, I don't mind writing another paper on that. Yeah, it's always good to have. But thanks for bringing that point up.
Okay, no problem. Yeah.
Okay, so I will probably end on this slide, and I just say a big thank you for my collaborators, and we hope to continue to build TaskGen. So we hope to seek your feedback. Okay, it's not a one-way download thing. Like, we hope that you will take up TaskGen, use it. If you face any issues, please feedback on the Discord channel or on the GitHub, and we'll try to solve it. And together we make this one of the best. In fact, I would like to say this is the best open source agentic framework. Okay, and yep, let's do it together. And I'm looking forward to see what you build with TaskGen. I will have another session to talk about TaskGen's projects, so do reach out to me if you want to present your project as well. That session, we can talk more in depth about all this. But if not, thanks so much for attending today, and yeah, I'll see you around. Okay, bye, everyone.
All right, thanks everyone.
Bye.
Bye everyone.